Okay, what I'd like to do in this module is really talk to you about some basic circuit analysis techniques. And the first thing I want to talk about is Ohm's law. Okay, now Ohm's law is an empirical law, which means it's actually derived by effectively experimentation. Now what Ohm's law states is that if I have a resistor, R, and we have a current flowing through that resistor, which is I, that develops a voltage across it, which we'll call V. Ohm's law simply states that the voltage across that resistor is equal to this current, I, times that resistance, R. All right. Now, look, just a couple of things to think about here, and really this is, I guess, a bit of a discussion on what I'm calling defined directions, okay? Let's imagine I have a resistor sitting here, okay? And if I actually define the direction of that current I, to label my voltage to be consistent with that defined direction, I'll label it as plus, minus, and I'm going to call that V. All right? So in other words, this current is flowing from a high to a low. So in other words, let's take another example. Let's say I have a resistance here. Let's say the current is flowing in this direction. Once again, we're going to call it I. How would I label my voltage across that component, that resistor? Well, I'm going to label it plus, minus, and I'm going to call it V. Now, if I actually maintain that consistency throughout the problems we're going to solve, then I'm going to keep myself really out of a lot of trouble. And I think it's important that we actually do that. All right, so that's Ohm's law. Another law which I'd like to talk to you a little bit about is, and we'll look at some examples here, is what is called Kirchhoff. Look at the spelling here. Kirchhoff's voltage, V-O-L-T-A-G-E, voltage law. All right. Now, what does Kirchhoff's voltage law state? It really says the sum of the voltages around a loop is equal to 0. All right, let's take an example to show that. So supposing I had a voltage source here, we'll say that's 20 volts, and we'll put a couple of resistors in here, like this. I've got another voltage source sitting over here, and I'm going to say this guy maybe 15 volts. So there's my little circuit. I'm going to call this resistor, I'll put a value in here. Let's say it's a 1K resistor. Let's say that's a 2K resistor. All right. What about my defined current direction? Well, it's arbitrary in a way. You can choose it to go this way, you can choose it to go the other way. Does that mean that the actual current is going in that direction? Not necessarily. If I define the current direction, for example, going, let's say this way, I'll just call it I, it may turn out that that current is a negative number, which means that the current really was going the other way around. Would I change anything? Absolutely not. I would just simply record that I is equal to some negative number. All right, so let's define the current in that direction. Label my voltages here. All right, let's do that. So I've got a voltage, what? Plus, minus. I'm going to call that voltage, let's say, V1. Okay, current flows along in this direction. Plus, minus, I'm going to call that voltage, let us say, V2. Okay, so I've got my labeling now of that voltage consistent with the way I actually define that current. All right, so then what we'll do is we'll apply Kirchhoff's voltage law, and we're going to sum these voltages around the loop. Does it matter which way I go around the loop? Absolutely not. Really doesn't matter. Go clockwise, anti-clockwise, doesn't matter. All right, well, let's go clockwise. There we go. Let's have a starting point. Let's start here. Now, another little convention is that if I'm traveling around the loop and I go up in voltage, I'm going to call that guy positive. If I drop in voltage, I'm going to call it negative. Okay? So here we go. I'm going from a minus to a plus. I'm going up in voltage. It's like going uphill, we'll call it positive. I'm going to say that's a 20. Next voltage, that's a minus to a plus. I'm going up. I'm going to call that a plus V2. As I come around the loop, next voltage, minus to a plus, I'm going to call that a plus V1. Continuing on around the loop, I go from a minus to a plus, I'm going to call that plus 15. I've now completed my loop, and I'm going to sum that to 0. Okay? All right, well, what about V1 and V2? well, look, let's use Ohm's law to evaluate V1 and V2. Well, that would simply say that V1 is equal to what? I times 2K. V2 is going to be I times 1K. So let's do that. So that's 20 plus V2. Well, that's I, isn't it? So there's I times 2K. Plus V1, which is I times what? The 1K. So that's I times 1K plus the 15, and all of that is equal to 0. All right, so now what should we do? Well, we should basically get all our terms together, shouldn't we? Yes, we should. So we'll take the 20 and we'll add the 15 to it, so that's 35, plus how many i's do we have? We have 1k here, 2k here, 1k here, means we've got 3k's, right? So that's I times 3k, all of that is equal to 0. Okay, let's take this to the other side. And so what do we have now? We have 35 is really equal to I times 3k, but it's a minus, isn't it? And so therefore, what is I? I can now say I, and I think that's obvious, is equal to what? It's equal to a minus 35, and that's divided by 3k. Notice in this particular example that because of the direction that we defined I has come out to be a negative number. Now, I wouldn't change anything. I'm not going to go back and suddenly say, oh, I need to draw the current the other way. I'm simply recording that I, according to that defined direction, is a minus 35 over 3k. And I just simply leave it that way. And so if I wanted to figure out what V1 was, V1, of course, is just I times 2k. If I wanted to figure out V2, it's just simply I times the 1k. Okay, next I want to talk to you about Kirchhoff's current law. Well, what is this? Well, basically Kirchhoff's current law is simply stating that the sum of currents entering a node is equal to 0. All right, let's draw a node. All right, so what we've got is a resistor, let's say, connected here, a resistor connected here, and maybe a resistor connected over here like so. All right, so let's define a current direction I1 here. Let's say we've got a current I2 coming in here, and let's say we've got another current I3 coming in here. Well, Kirchhoff's current law simply states that, as I said before, the sum of the currents entering this node is equal to 0. All right, so a little convention. If the current's going into the node, we're going to call it positive. If it's going out of the node, we're going to call it negative. So this is going in, so we've got what? I1, positive. This is going in, plus I2. This is going in, plus I3, and all of that is equal to 0. All right, so what I want to do now is take a little problem, a little example that perhaps uses basically Kirchhoff's voltage law, current law, and also Ohm's law. So here we go with a little problem. All right, so I'll draw this for you. We'll make it up as we go along here. So I'm going to say, look, I've got a 20 volt source sitting here like so. All right, I've got a resistor here, which I'll call 1K. Another resistor sitting over here, we'll make that a 3K resistor, and another resistor over here, I'm going to call that 2K, and I've got a voltage source, let's say sitting over here like so. That will be the circuit that we're going to deal with. All right, okay, let's make this guy over here, let's make it 10 volts. All right. Now, it could be that you're asked to determine maybe the current in the 1K, or the current in the 3K, or the current in the 2K, or the voltage across the 3K, etc. So we really need to find out basically what's going on, what the currents are, etc. So we need to define current directions. As I say, that is arbitrary, really. I don't need to stress about it, thinking about which way the real current is going, the actual current direction is. Don't need to do that. So I'm going to define this current here as my I1 current. I'm going to define this current over here as my I2 current, and I'm going to say I3 is flowing in this direction like so. These are the defined current directions. First step. I'm going to label my voltages now to be consistent with that defined direction. So what have I got here? Well, I've got a plus minus. That would be my voltage across that resistor. I could label it, could call it V1 if we want to, or I could just leave it plus minus. So we know V1 would be I1 times 1K. My defined voltage direction across that 3K is plus minus, and a current going in this direction, so I've got a plus minus labeling of voltage there. Okay, So what are we trying to solve? We've got a node sitting here. Maybe we're trying to solve for those currents. Okay, what can we do? Well, we can take a loop here. Okay, I'm going to say that's loop number 1. Okay, and we're going to sum the voltages around that particular loop. All right, let's go for it. Does it matter which way around the loop? No, it doesn't. So, all right, I'm just going to go clockwise around that loop. I'm going to start at this point and simply go around summing those voltages. And I'm going to, as I say, take a step here and say, I know that voltage. Ohm's law says it's I1 times 1K. So here we go, starting here. So what have I got? I've got going up in voltage. I've got a 20, haven't I? As I come across here, I'm going from a minus to a plus to a minus. I'm dropping in voltage. So that's really a minus I1 times 1K. Continuing on, I'm dropping again, plus to a minus. So that is a minus. This time it's what? An I3 times the 3K. I'm back to the beginning. All of that is equal to 0. Okay, that's one equation, 2 unknowns. All right, we can take another loop over here. Does it matter which way around the loop we go? No, it really doesn't. Absolutely not. So I could go the other way if you wish. So we can go this way. So that's my loop 2, if you like. So let's do it. We'll start maybe here. We're going this way. So we're going from what? A plus to a minus. So that's really a minus 10, isn't it? Yeah. As I come around my loop, I'm going from a plus to a minus. That means I'm dropping. That's a minus what? I2 times the 2K. And as I continue on round, I'm going from a plus to a minus now, am I not? Plus to a minus. I'm dropping again, so that's a minus what? I3 times that 3K, and all of that is equal to 0. So I've now got 2 equations. There are 3 unknowns, okay? The 3 currents. So where do I get my third equation from? Well, I'm going to get it now really from that node, and I'm going to sum the currents really at that node. So the question is, what's going in? Well, I1 is going in, isn't it? There it is. What else is going in? I2 is going in, so that's a plus I2. I3 is going out, so that's a minus I3, and all of that is equal to 0. So I now have 3 equations with 3 unknowns, and I'm now really in a position to start solving for those unknowns.